Chapter 2 Elementary Particle Dynamics. This chapter introduces the fundamental forces by which elementary particles interact and the Feynman diagrams we use to represent these interactions. The treatment is entirely qualitative and can be read quickly to get a sense of the lay of the land. The quantitative details will come in chapter 6 through 10. The four forces. As far as we know, there are just four fundamental forces in nature: strong, electromagnetic, weak, and gravitational. They are listed in the following table in order of decreasing strength. Strong force, strength 10, theory, chromodynamics, mediator, gluon. Electromagnetic force, strength 10 to the power minus 2, electrodynamics, mediator, photon. Weak force, strength 10 to the power minus 13, theory, flavor dynamics, mediator, W and Z. Gravitational force, strength 10 to the power minus 42, theory, geometrodynamics, mediator, graviton. The strength of a force is an intrinsically ambiguous notion. After all, it depends on the nature of the source and on how far away you are. So, the numbers in this table should not be taken too literally, and especially in the case of the weak force, you will see quite different figures quoted elsewhere. To each of these forces, there belongs a physical theory. The classical theory of gravity is, of course, Newton's law of universal gravitation. Its relativistic generalization is Einstein's general theory of relativity. Geometrodynamics would be a better term. A completely satisfactory quantum theory of gravity has yet to be worked out. For the moment, most people assume that gravity is simply too weak to play a significant role in elementary particle physics. The physical theory that describes electromagnetic forces is called electrodynamics. It was given its classical formulation by Maxwell over 100 years ago. Maxwell's theory was already consistent with special relativity, for which it was in fact the main inspiration. The quantum theory of electrodynamics was perfected by Tomonaga, Feynman and Schwinger in the 1940s. The weak forces, which account for nuclear beta decay, and also, as we have seen, the decay of the pion, the muon, and many of the strange particles were unknown to classical physics. Their theoretical description was given a relativistic quantum formulation right from the start. The first theory of the weak forces was presented by Fermi in 1933. It was refined by Li and Young, Feynman and Gell-Mann and many others in the 50s and put into its present form by Glashow, Winberg and Salom in the 60s. For reasons that will appear in due course, the theory of weak interactions is sometimes called flavor dynamics. In this book, I refer to it simply as the Glashow-Winberg-Salom GWS theory. The GWS model treats weak and electromagnetic interactions as different manifestations of a single electroweak force, and in this sense the four forces reduce to three. As for the strong forces, beyond the pioneering work of Yukawa in 1934, there really was no theory until the emergence of chromodynamics in the mid-70s. Each of these forces is mediated by the exchange of a particle. The gravitational mediator is called the graviton. Electromagnetic forces are mediated by the photon, strong forces by the gluon, and weak forces by the intermediate vector bosons W and Z. These mediators transmit the force between one quark or lepton and another. In principle, the force of impact between a bat and a baseball is nothing but the combined interaction of the quarks and leptons in one with the quarks and leptons in the other. More to the point, the strong force between two protons, say, which Yukawa took to be a fundamental and irreducible process, must be regarded as a complicated interaction of 6 quarks. This is clearly not the place to look for simplicity. Rather, we must begin by analyzing the force between one truly elementary particle and another. In this chapter, I will show you qualitatively how each of the relevant forces acts on individual quarks and leptons. Subsequent chapters develop the machinery needed to make the theory quantitative.